Ionization energy is another periodic property. And ionization energy is very useful when you study chemistry, because it tells you how easy it is for that atom to become positively charged, to form a positive ion, what we call a cation. It's defined as the energy required, some energy you have to spend. You are taking away an electron from an atom, the atom is not going to like it. So it's energy that you need to spend to take away an electron from an atom. The atom, it needs to be in gas phase and become a positive ion. We always define both ionization energy and the next energy I'm going to talk to you about, electronic affinity, are defined in gas phase, because you also need energy to make something liquid, solid, or gas. So not to mess that up, it's all defined in gas phase. So the energy required to take an electron away from an atom, so the atom becomes positively charged, and it's defined one at a time. So you take one electron and the atom becomes positively charged. Then you take another electron and the atom becomes an ion, but then it becomes an ion with two negative charges. In theory, if you spend enough energy, you can take one by one all the electrons that an atom possesses. So francium has 87 electrons. You could one by one taking them all in sequence. In practice, typically 1, 2, or 3 electrons is what normally happens in a chemical reaction. So if we think about what we talked about in the previous slide about atomic volume, I want you to stop I wanted to stop the video a second and have a little think about this. When will it be easier to take away an electron from an atom? If the atom is very large or the atom is very small? What do you think will be easier? To take an electron from an atom if the atom is very large or if it's very small? Stop the video now. So if I think about it, the smaller the atom is, the more difficult it will be to take that electron away, because the closer it will be to the nucleus, so the most attracted it's going to be to the nucleus. So if you have an atom like francium that has 87 electrons and you're taking one electron away, the furthest away from the nucleus, well, that will require some energy. But when you compare that with lithium here, that has 3 electrons, so they're very close to the nucleus, and you take one, that electron you're taking away is much, much closer to the nucleus. So it will be much more difficult to take away. So the smaller atoms are at the top of a group. So ionization energy increases as you go up a group, because the atoms become smaller and it becomes more and more difficult to take away an electron from them, because those electrons are closer to the nucleus. And as you remember, the size of the atom decreases across the period from when you go from the left to the right, because you have that more powerful positive charge in the nucleus that is more efficient at attracting the electrons. So that means that ionization energy is going to also increase as you move from the left to the right, because the smaller the atom is, the more difficult it is to take an electron away from it, because that electron will be closer to the nucleus. So this determines that if you have an atom at the bottom of this group, it will find it much easier to become a positive ion than if the element that is at the top of that group. And in terms of the whole periodic table, the more you move towards the right, the more difficult it is to convince that atom to take an electron away from that atom, or a second electron, or a third electron, because they are much more retained. And actually, atoms in the top right hand corner of the periodic table do not like to act as positive ions, while atoms in the left side of the periodic table, they do find it much easier to act as cation, as positive ions. And that's one of the reasons why metals have this sort of very rich chemistry in which they become positive ions, and they might lose one electron, or they miss a second one, or a third one, and those are energetic considerations on what's the most stable electronic shell that they can come up with.